let's start. Okay, so these are the examples we did in the last class. If any one of you missed it, I will share the link of that recording as well, inshallah. Now, basically, if you look at this is the order when you have to put the oxidation numbers of the elements in a compound, then you always follow this order. That first you have to identify the net charge. If it's a compound, then the net charge will be 0. And if it's an ion, so there must be some positive or negative charge on it. After that, we are going to identify if there is any element from group 1, 2, and 3, then we will going to put their oxidation number. Then if there is a hydrogen, so we are going to put a positive one or a negative one on hydrogen. It depends. If this hydrogen is bonded to a metals from these group, then it is going to be its oxidation number is then in that case -1. And if this hydrogen is bonded to a non-metal, then its oxidation number is +1. Is this understandable to all of you?
Yes, sir.
Okay. Then after putting the oxidation number of a hydrogen, then we will look for the most electronegative element, and we are going to put its oxidation number. So if you recall the order for the most electronegative elements, so the most electronegative one is fluorine, then oxygen, then nitrogen, and then chlorine. So if there is any one metal among these, so we are going to put the oxidation number of that element first, after putting the oxidation number of hydrogen. And in case if there are any two, so out of those two, which one have a higher electronegativity or which one is the most electronegative, we will first put its oxidation number, then the oxidation number of the other. And after this, if there is any other element which is left in that compound, then we are going to put its oxidation number. And when we put these oxidation numbers, so keep in mind when you sum those oxidation numbers, they are always becomes equals to the net charge of the compound, which we have decided in the first step. Okay, is this clear to all of you?
Yes, sir.
Yes, sir.
Okay, yes, Ahmed, Kubra, and Hamza.
Yes, sir.
Okay, let's start with this compound, for example. Do the working with me, so it will be, it will get more easier for you guys. So it's S2O3, right? So if first we go for the net charge, so the net charge is -2. After that, we have to identify whether there is an element from group 1, 2, and 3. So there is a sulfur and oxygen. So there is no element from group 1, 2, and 3. Then after that, next, if there is a hydrogen, so there is no hydrogen. Then the most electronegative element. So in this case, the most electronegative element is oxygen. So what we are going to do, we are going to put the charge of oxygen. In this case, it's going to be -2. And there are 3 oxygen atoms, which makes it -2 times 3. Till here, is this understandable to all of you?
Yes, sir.
Okay, yes, Ahmed and Amna.
Yes, sir.
So it means that the net charge is -2. Over here, it becomes -6. So what will be the charge over here? That if I place that charge on sulfur and then I add both of the oxidation number of sulfur and oxygen, I will get -2. Yes, what will be that charge?
Sir, -2.
-2 and -6, isn't it makes it -8?
Sir, +2 and times 2. It would multiply by 2.
+4. And as you see, there are 2 sulfur atoms. So it is going to be +2 times 2. Is this understandable?
Yes, sir.
Okay. Yes, Ashil?
Sir.
Yes,
Yes.
Ahmed?
Yes, sir.
Okay. Now, have a look at next case. It's Fe2O3. The net charge is, what is the net charge on this Fe2O3 iron 3 oxide? There is no net charge, so it means it's 0. Then we have to look for the any element from group 1, 2, and 3. So there is no element from group 1, 2, and 3. Then we have to look for hydrogen, no hydrogen. Then we have to look for the most electronegative one, which is oxygen over here. So it's going to be -2 again. And there are 3 oxygens, which makes it -6. So what will be the charge on iron? So we'll get a 0 net charge. Yes. Yes,
So +6.
+6. And if you see there are 2 irons, so it means each iron have a +3 oxidation number in this compound. Yes, is this clear to all of you?
Yes, sir.
Okay. Now, here we have S4O82 negative. So why don't you guys try this S4O82 negative? Let me do the start. The net charge is -2. And then send me your workings quickly. So Hamza, it's a collective charge of 4 sulfurs. So what will be the charge of 1 sulfur? You have to show that.
So 7/2.
Will it positive or negative?
So it will be positive.
Okay, let's see. Yes, received from Kubra. Yes, Amna, Ahmad, and Ashal. Okay, received from Amna. Very good. Yes, Ashal and Ahmad.
So please tell me what I have to do. My internet was disconnected.
You have to find the put the oxidation numbers of sulfur and oxygen in this S4O82 negative.
Okay, okay.
Okay, Ashal, wait a minute. Okay, so there is no element from group 1, 2, and 3 over here, right? There is no hydrogen. Then the most electronegative one is oxygen. It's -2 times 8. So it means, just give me a minute, please. Okay. So it is going to be minus 16 and over here it's minus 2. So it means sulfur must have a plus 14. And how many sulfur are there? 4 sulfur are there. So each sulfur have positive 3.5 or positive 7/2 oxidation number. Yes, is this clear, Ashal?
Yes, sir, it's clear now.
Ahmed?
Yes, sir.
Okay. Now, have a look at this. In this case, the net charge is 0. Then potassium is from group 1, so plus 1. No hydrogen. Most electronegative one is oxygen, which is minus 2 times 4, which makes it minus 8. Net charge is 0. Potassium is plus 1, so it means here in the middle it must be plus 7. Yes, is this understandable?
Yes, sir.
Yes, sir.
Yes, Amna, Hamza, and Kubra.
Yes, sir.
Okay. Now, these are for you guys, and you have to follow the same order. Now, do it quickly and WhatsApp me.
Sir, you kindly tell the CH3COH1,
Yeah,
please.
I'm going to discuss it. Please wait.
Okay, sir.
If I do it for ClO negative, so the net charge will be minus 1. Most electronegative is minus 2, which means chlorine must have a plus 1 oxidation number. Then if I'll do for NaClO3, as we see, net charge is 0. Sodium is from group 1, so plus 1. Oxygen is most electronegative. Minus 2 times 3 makes it minus 6. Sodium is plus 1 and net charge is 0. So chlorine must have a plus 5 oxidation number over here. Is this clear to all of you? Then when we go for a NH4 positive, so the net charge is plus 1. There is no group 1, 2, and 3 element. Then we have a hydrogen. So plus 1 times 4 makes it positive 4. So the nitrogen have a minus 3 oxidation number. And that's how we will get the negative 1 charge. Oh, positive 1 net charge. In case of hydroxide, the net charge is minus 1. And as we know, hydrogen is plus 1 and oxygen is minus 2. So we'll get a net charge of minus 1. Now, in these here, NO2, the net charge is 0. No element from group 1, 2, and 3. No hydrogen. Then we have our oxygen. So minus 2 times 2 makes it minus 4, which means nitrogen have a plus 4. Then we have N2O5. The net charge is 0. No element from group 1, 2, and 3. No hydrogen. Hence, most electronegativity is oxygen, which is minus 2 times 5, which makes it minus 10. So on nitrogen, there must be a positive 10. And as there are 2 nitrogens, so each nitrogen have a plus 5 oxidation number. Is this clear to all of you?
Yes, sir.
Yes, sir.
NO3 negative. So the net charge is minus 1. Most electronegative is oxygen, which is minus 2 times 3 makes it minus 5. So nitrogen over here also have a plus 5 oxidation number. then CH3OH. So no element from group 1, 2, and 3. Net charge is 0. Then we have a hydrogen. So +1 and +1 times 3. So that makes the whole charge +4. So oxygen have a -2 and carbon have a -2. So as a result, the net charge becomes 0. Is this clear? Okay. Then we have a SO4 negative. SO4 2 negative. So the net charge over here is -2. Most electronegative is oxygen, which is -2 times 4 -8. So sulfur must have a +6 charge. So that's why we will get a net charge of -2. Is this clear?
Yes, sir.
Now H2C2O4, which is also called ethane dioic acid. Net charge is 0. Most hydrogen is there, so +1 times 2. Then most electronegative oxygen, which is -2 times 4, makes it -8. So carbon must have a +6, and there are 2 carbons, so each carbon have a +3 oxidation number. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay, it's a little tricky. So let's see how we do it. You all know its structure, that with the first carbon, there are 3 hydrogens bonded, right? So if I'll draw its displayed form, where all the bonds are shown, it will be more easier for you guys to understand how we will put the oxidation numbers. So as there are hydrogens, so each hydrogen have a +1 charge, right? And that's why we are going to put a +1 times 3 over here and +1 over here, and the net charge is 0. Is this clear?
Yes, sir.
Okay, now if you see these 3 hydrogens, each is +1, so the collective charge of these 3 hydrogen is +3, right? The net or the collective charge of these 3 hydrogen is +3, so it means if this carbon is bonded to these 3 hydrogens, then this carbon must carry a -3 charge, so this carbon becomes -3. And then oxygen is most electronegative, so this oxygen is -2, and this oxygen is also -2. -2 and -2. So as these 2 oxygens are bonded to a carbon, so this carbon must be +3. Now if you add them, you will get the net charge of 0. So that is how we will put the oxidation numbers over here in ethane dioic acid, in ethanoic acid. So this carbon is going to be +3. Yes, is this understandable to all of you?
Yes, sir.
Yes,
Yes,
Amna,
sir.
Ashal, Ahmed.
Yes, sir.
Okay,
Yes.
okay. So now the next thing that we need to do is that by the help of these oxidation numbers, we can write the systematic names of the compounds. So let's have a look over here. Okay. So we know when there is a negative ion having a single element, then its name, the last part, the suffix is replaced by id. So Cl is chlorine, but when it becomes a negatively charged ion, it becomes chloride, right? In the same way, S2 negative is sulfide, P3 negative is phosphide, Br negative is bromide, N3 negative is nitride, and O2 negative is oxide. Is this understandable to all of you? Yes?
Yes, sir. Yes, sir.
Okay.
Yes,
Now,
sir.
what we call this ion? Can anyone recall its name? It's sulfate, right? So if you see, it's a polyatomic negative anion where an element is bonded to oxygen. So when that happens, then the last part of the name is replaced. The suffix of the name is replaced by 8. So ClO3 negative is a chlorate, SO4 2 negative is a sulfate, PO4 3 negative is a phosphate, and NO3 negative is also a nitrate. Is this understandable?
Yes, sir.
Yes, Ahmed, Hamza,
Yes, sir.
Amna, and Kubra.
Yes, sir.
Yes, sir.
Okay, now then in the systematic name,
Yes.
after this we will put the oxidation number of the element. So here see chlorine is +5. So I'm going to write chlorate 5 ion. Here sulfur is +6. So in the systematic name it's sulfate 6 ion. Here phosphorus is +5. So it is going to be phosphate 5 ion, and here nitrogen is +5. So it's going to be nitrate 5 ion. Is this understandable?
Yes, sir.
That is how we do the systematic names. If you look over here, see it is SO3 2 negative and it is SO4 2 negative. So both are sulfate. But see the oxidation number matters in the systematic name. So here the oxidation number of sulfur is +4. So that is going to be sulfate 4 ion. It's a chlorate ion, but here the chlorine is +1. So this its name is going to be chlorate 1 ion, and here chlorine is +5. So it's the name of this ion is going to be chlorate 5 ion. Is this understandable?
Yes, sir.
Okay. So in the same way, PO3 3 negative with a 3 positive, so phosphate 3 ion, and then NO2 negative with a nitrogen positive 3 oxidation number, so nitrate 3 ion. So this is how we do the systematic name. And if you recall their normal names of these ions, so it is sulfide ITE, phosphide ITE, and nitrite ITE. But when we are writing the systematic names, then we always write these kind of polyatomic anions 8 in the suffix and then put the oxidation number of the element whose oxidation number is actually variable. Is this clear?
Yes, sir.
Okay. So in the same way, if you look at this, we know it's a nitric acid. But if I'm going to write its systematic name, so here the nitrogen is +5, so the systematic name will be nitric 5 acid. Here it's a sulfuric acid, but sulfur over here is +6. So the systematic name is going to be sulfuric 6 acid. It's phosphoric acid, but systematic name will be phosphoric 5 acid. Now, if you see over here, normally HNO2 we call it nitrous acid, but when we are going to write its name systematically, so the nitrogen is +3, so it is going to be nitric 3 acid, nitric 5 acid. See the difference? It's only in the oxidation number when we are writing the systematic names, and rest of the name is remain same. So H2SO3 is usually called sulfuric acid, but when we are going to write its systematic name, then it is going to be sulfuric 4 acid. Then it's simply phosphorus acid, but the systematic name will be phosphoric 3 acid. Is this clear? Yes, any questions in these naming? In the same way, when we are writing beside acids the other compounds, so in systematic name we are going to put the oxidation number. Okay, if any one of you have any query, please ask. Yes, Ahmed, is this clear?
Yes,
Yeah.
sir.
Okay, yes, Ashal and Hamza,
Yes, sir.
Yes, sir.
Amna and Kubra.
Yes, sir.
Okay. So in the next class, we are going to start the redox balancing. But before that, we have to get the concept of redox reaction, reduction and oxidation. We just discussed how to find the oxidation numbers, their rules, and then the way how to write the systematic names of these compounds. So you all are, I hope, familiar with reduction and oxidation. So when we talk about reduction, if some ion or atom gains electron, then that is called reduction. Oxidation is exactly opposite of this. Whether an atom or an ion loses the electron, then it is called oxidation. When we have to explain reduction in terms of hydrogen, so see here chlorine is gaining the hydrogen. So when some substance gains hydrogen, then it's a reduction. When some substance lost hydrogen, see hydrogen iodide, iodide over here lost hydrogen and turns into iodine, so it's oxidation. If some substance lose oxygen, so here if you see water, oxygen is lost and there is a hydrogen left, so it's reduction. And here if some substance gains oxygen, so hydrogen is gaining the oxygen turning into water, so it's oxidation. So another very important thing about this, whether reduction is taking place by gain of electron or by gain of hydrogen or by loss of oxygen, whenever reduction occurs, the oxidation number decreases. See over here, if you see it's +1, now it's 0. Here it's 0, it turns into -1. If you see chlorine, it's 0 over here, it turns into -1. If you see hydrogen, here it's +1 and here it becomes element, so it's 0. So whatever the case, it doesn't matter how the reduction is taking place, whether by gain of electron, whether by gain of hydrogen, or whether by loss of oxygen, the element which undergo reduction, its oxidation number always decreases. Is this point is clear?
Yes, sir.
Yes, sir.
In the same way, when the oxidation occurs, whether by loss of electron or by loss of hydrogen or by gain of oxygen, its oxidation number increases. See over here, the oxidation number of this sodium is 0 and here it becomes +1. The oxidation number of this chlorine is -1 and here it becomes 0. The oxidation number of this I is -1 because it's in the compound and here it's an element, so it's 0. The oxidation number of this hydrogen is 0 because it's element and here it's +1. So see, every element which is undergoing oxidation, whether by losing electron, whether by losing hydrogen, or whether by gaining oxygen, its oxidation number is increasing. So whenever the oxidation occurs, the oxidation number increases. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. So this is the thumb rule. In reduction, the oxidation number always decreases. In oxidation, the oxidation number always increases. Okay. So if any one of you have any confusion till here, please ask. Okay. So I'm going to keep the class till here only. In the next class, we will continue with the redox reaction and we will discuss a little about oxidizing agent and reducing agent, and then we will proceed to understand how we will balance the redox equations. And the next class will be on Friday from 3 till 5. So it will be a double class, okay?
Okay, sir.
Okay, sir.
Okay, sir.
Then. Take care, everyone.
Love,
Allah
sir.
Love.
Hafiz.
Love, yes.